I think most people will know ntop, will know Luca. They've been creating ntop, they've been creating pfring. So with Suricata, we've always been connected to these guys. And it's my great pleasure to announce them to you today. And they will be talking about sort of merging ntop and Suricata visibility. And I have to admit, I've never actually run ntop, and this I will listen with great interest. So please welcome Luca and Alfredo.
Thank you. Okay, let's start with a short introduction of what we do at ntop. Okay, ntop is an open source project, more or less like Suricata. So the code is on GitHub. And we also have a community. This is a larger community than what we have. So we have a Telegram channel, okay, so where people discuss, ask questions, something like that. And we're also part of the Intel Innovation Program that is somehow, helping us to tell the world that we exist. So just to make this long story short, what is the main difference between Suricata and ntop? That we are doing network traffic monitoring. So we look at the traffic, we want to understand what's going on, we want to give people an idea of what is happening on their network. So security for us is relevant, but is not the only focus. Suricata instead is doing security, okay, in a special way, so you know very well how it works. And the idea for us was to use Suricata in a way that our community understands, and also to, let's say, fix some limitation of Suricata, because Suricata, in a way, is a probe. Okay, so it's a sensor, I don't know how you want to call it. So it's something that you put on a network, doesn't have a user interface, is doing, something with the rules and with traffic analysis, and is reporting this to other people in a format that people are not able to visualize. That's why there is a market, a big market around Suricata and Zik, so I don't know if I can pronounce this word here, for tools that somehow collect this data and create some nice reports. So the idea today is to try to merge these two words together, okay, from a network monitoring perspective. So I will show you that in a second. So in essence, what is network visibility? It is the ability of understanding and evaluating what is happening on the network from a big picture. So for Suricata, it's looking at each individual flow. Here we are talking about the whole network. So I want to see, for instance, who are the top talkers, what is the scanner, and why this computer that has never done BitTorrent is now doing BitTorrent. So this is the typical question. So in Suricata, instead, you focus on a single flow. So you're saying if this flow contains something like this, then there is a problem. But there are many other problems. For instance, if my printer is doing BitTorrent, there is a problem, definitely, that Suricata is not able to unveil. So the idea is that to merge these two work together to create a better tool, a better open source tool. That is the sum of these two. ntopng in particular is one tool that we have created that has a user interface that is basically something that an end user is using, even though it's for technical people. Okay, so no log files. And the point is that in Suricata, because of the lack of a user interface, basically people use Suricata in combination with other tools. So you have tools for downloading the rules, you have tools for displaying what is happening. Many people send this data, for instance, to Elasticsearch, store everything there, and they use Kibana for creating the dashboard. However, we don't feel that this is the good way of doing that, because simply Elasticsearch is a generic tool, doesn't have any knowledge of host, flow, issues. For Elasticsearch, it's an IP address, it's a string, it's a number. So that's why we have created something that we are going to show you today that tries to unify these two words together. And like I've said before, Suricata is a pure sensor. So it is very good at reporting about flows. You have seen in the previous presentation that how large is the JSON. But again, this is not a tool for end users. So you need something after Suricata that is able to understand and correlate it. So in essence, we want to create some sort of augmented security, I would say. So where we combine security with visibility, not focusing at a single event, but focusing at the big picture. focusing on the behavior of a device, okay? So I'm not talking about machine learning or very complicated stuff, even something very, very basic that is pretty standard in the world. So I'm usually not in Amsterdam today. If today I'm in Amsterdam, maybe this is a warning, something like that, okay? Something very simple. So the idea is to put this thing together and to exploit Suricata for what it does very well. So namely, generate an alert. So in essence, this is a typical question that we want to answer. So this is a picture of one of the pages of ntopng. So we see this is a bubble chart, okay, something not really super advanced. So you see that there are some hosts that are doing something that we call misbehaving. So namely, there are flows that are somehow special because we don't expect them to see in that format. That in the Suricata world means they have violated a rule. In our world, it means this and also something else, like, I don't know, Luca is not downloading big files usually, today has downloaded a big file, okay? So correlate these two events all together, and according to a host, you can see this picture. So if you see these two circles, it's immediate that if you can click on the circle, you will immediately jump to the host and see what is going on. So this is what I told you before. So I have the ability of merging single events into something more comprehensive. And of course, to look at alerts, okay, like you usually do, but with a user interface. No JSON, no Eve, nothing like that. So a GUI, so a mouse, a click remotely. This is where we want to go. In addition, we see that Suricata, for instance, is blind with respect to some information that for us is relevant and that we have solved. For instance, container information. Today we have many containers. Okay, so there are organizations that really rely on containers. Suricata does not have this type of information. So for us, merging this information is relevant because if I know that a certain flow, and we know because this is something we have done, is generated by container X pod Y, and Suricata says, okay, but there is a problem with this container because I've seen that this flow has violated this signature. So there's an emerging threat rule, let's say, that says that there is something wrong. With this integration that we are going to talk today, it's possible to jump from the Suricata alert to the container, to the pod, to the user, and to the full path of the application that we have learned from eBPF that has created the problem. So I can tell you, go in this container, find this file, and this will be the problem. Of course, now I'm talking about containers, but the same applies to standard PCs without any container, because eBPF is also there. So the idea is to merge these two worlds together, okay? That is the power of, from a point of view, what we do. So in essence, ntopng has very nice features, but we miss what is Suricata providing us. So we have said some time ago, why instead of doing what many, unfortunately, open source projects are doing, so redo what others have done, instead we integrate. Because this is, I think, is the power of open source, the ability of being open, not just in source code, because very few people look at the source code, but being open in the information that we export, in the format that we export. And Suricata is very open also on that, not just on the source code. So this is the idea of this talk, and the motivation, to merge the best of this world, to create a better tool that is able to exploit this information and to report them to users with a user interface. So I don't know if ntopng will be a user interface for Suricata. For us, it's definitely the case. But it's also an opportunity for this community from our point of view. So looking at the limitation of Suricata, for instance, take this in a positive sense. If, for instance, the lack of the packet inspection, if we look at the traffic today, this is a typical chart that we have in a Wi-Fi, but I think it will be more or less today here. Most of the traffic is encrypted. So there is not much you can do with that. So there are no many signature matching. We are talking about JA3 here before, but JA3 are nice to have, but they are not anything more than that because they can lead to false positives. So also running scripts like this, so this is a typical rule. So if you have an IRC bot on a port that Suricata doesn't want to look at, there is a problem because you're blind, you're totally blind. Instead, using the packet inspection means, on whatever port you see IRC, there is a problem. Okay, if there is a long-standing flow going to IRC from my network, and my network doesn't have this traffic, usually, there is a problem. So the idea is that we want to also contribute to Suricata in this term, with things that we see. So for instance, a lot of too many negative DNS responses, for instance. Usually my host is positive, has a very good positive, negative response ratio on the DNS, and now it's becoming, a nasty machine. Why that? So for Suricata, this is normal, this is okay. But for us, because we know the behavior of this machine, we say, well, there is something wrong now. So the idea is to merge these two things and turn limitation into possibilities. This is the idea. So in essence, we want to unify visibility and security in a single tool, giving people what we have and adding what Suricata can provide us. So this is the message that we want to give today in a very simple form. So no configuration, nothing. You just, Alfredo will show you that, how to do this. In essence, to provide something to the Suricata community that is coming from the network monitoring community. So we take security, we give you visibility, and merge together. So this is the key of the talk. Please.
Okay, thank you. I will talk a little bit about the implementation of the integration of Suricata with ntopng. So what you see is the ntopng architecture. So ntopng is able to process both live traffic, so raw packets, and flows or events. So ntopng can collect flows or events through ZRMQ or Syslog, which is what Suricata is using with the Eve output. The core engine of ntopng is C++ and Lua. Lua was initially used for the front end, for the user interface, but today half of the core engine is actually in Lua, most of the logic inside ntopng. We use Lua also to provide an API for the community to extend ntopng with simple scripts. We also provide a RESTful API that can be used to access the live information, real-time information, and integrate ntopng with external tools. For processing live traffic, ntopng is also using our deep packet inspection library, NDPI, in order to detect the layer 7 the application protocol. And we use InfluxDB or RD for storing time series and Redis as a cache. So this is the core engine of ntopng. So you already know what is the Eve output in Suricata. We have seen a talk before. So Suricata is exporting events including alerts, flow records are net flow, application layer metadata. So for selected protocols, we have parsing metadata, and also information about the files that Suricata is extracting from selected protocols and storing to disk. So in ntopng, we have a Syslog interface, as we have seen before, that can be used to collect records from Syslog. And we have Lua scripts to handle those records. So for each application, for each source application like Suricata, we have a small Lua script which is getting the records, processing them, and injecting the information to the ntopng engine. So alerts generated by Suricata are collected through this Syslog interface. And what we want to do, as we have seen before, as Luca said, we want to integrate, we want to merge the network metrics generated by ntopng with the security alerts generated by Suricata. You can do this binding the physical interface that we have in ntopng, where live traffic is getting processed by ntopng, with the Syslog interface. So the result is a single logical interface where you have correlated informations from both sources. So this is just a sample configuration. So in essence, here we are starting ntopng with a physical interface, ETH0, and the Syslog interface where we are receiving events from Suricata over TCP. After running ntopng with this configuration, all you need to do to correlate the informations is to go to the ETH0 interface configuration and select Suricata as companion interface. So at this point, we are able to correlate, for instance, flows processed by ntopng with the alerts coming from Suricata. If we go to the Suricata interface in ntopng, we can see standard information for an interface like traffic received or sent. In addition to the standard interfaces that ntopng is producing, we can see additional information coming from the Suricata statistics, for instance, like processed or dropped packets or the number of rules loaded in Suricata. This is coming from the Eve output. We can see alerts, of course. So in this case, for instance, the first alert is a malware. And we have the information coming from Suricata like, hey, this alert is about a Trojan with this description. And we have the 5 tuple. We can click on the 5 tuple, let's say, on the flow, and get the flow details. So in this screen, we can see that we have network matrix computed by ntopng merged with information coming from Suricata. So, for instance, we can see, I don't know, out-of-order packets for TCP, packet loss, the network latency, the application latency, all metrics which are generated by ntopng. In addition to this, we have, for instance, the malware alert generated by Suricata, and other informations, including the community ID and the Suricata flow ID that we can use to correlate the informations. Suricata is also able, as I say, to generate application metadata. Like for HTTP, we can get the user agent, the content LAN, the MIME type, etc. And the protocol parser and stream assembly engine in Suricata are able to store files to disk and provide through the Eve format the information about those files. All those informations can also be ingested by ntopng. In some cases, they can be used to generate metrics when they are natively supported by ntopng. For instance, I don't know, the HTTP method is natively supported by ntopng. In other cases, we have additional informations which are not natively supported by ntopng, and they are displayed as additional informations in the flow details. In this case, for instance, we have an HTTP flow, and we can see information about, again, metrics generated by ntopng. In addition to those informations, we have additional information coming from Suricata, like the content type, the content LAN, and information about the file info information, let's say. So we know if this flow contains a file, and if this file has been dumped to disk. And in that case, we have the file ID that we can use to retrieve the file from disk. It would be nice to add here, for instance, a link to download the file directly. OK, now we have seen how to use ntopng to process live traffic, and at the same time, Suricata processing the same traffic and merging the two informations together. What you can do, you can also use Suricata to generate net flow. So ntopng can just receive net flow in addition to alerts events from Suricata instead of processing live traffic. For instance, we can have a remote Suricata sensor exporting information about flows and alerts instead of processing traffic in ntopng. The drawback of this configuration is that Suricata cannot compute network matrix because it doesn't look at the packets. So ntopng is not able to see, for instance, the inter-arrival time of packets, cannot run DPI on the packets, on raw packets. So you have less information, let's say. So this is an example of flows received by Suricata, by ntopng from Suricata. As you can see, in some case, we are able to guess the protocol based on the port or on the parsing metadata provided by Suricata. In other cases, we are not able to see the application protocol because we have no visibility on raw packets, and we cannot analyze the raw packets with our deep packet inspection library. So this is an example of flow details without packets, so with flow information coming from Suricata. As you can see in the orange box, we have a few informations about metrics, and then we have all the informations about coming from Suricata. For instance, in this case, this is a TLS flow, and we have all the certificate information, etc. Instead, in the previous configuration, where we have access to packets, we can combine all the metrics coming from ntopng, which is able to look at packets at live traffic, with information coming from Suricata. So the best configuration would be to have both access to live traffic and alerts or layer 7 information from Suricata. OK, so it's time to wrap up. Luca, do you want to?
Yes. So in essence, I hope that is clear our strategy. The strategy is that we want to turn Suricata into a NetFlow-like collector, so that in case you have multiple sensors available in your network, so unless you really need NetFlow or IPFIX, you can use Suricata as an ingest for us. Limitations are because Suricata does not export everything that NetFlow collector would expect, but this is our task to make this conversion as smooth as possible, and also to use Suricata to complement packet-based information. So you can use these two tools. But the idea here is that, like I've said, we want to merge visibility and security. And even though we like Suricata very much, we believe that the future brings us to add additional tools into this matrix. So in essence, if we have interesting information, let's say, coming from a commercial firewall, and this is typically the case, why not to use it? I tell you something, with the NDPI library that is still open source that you can find at the bottom of this, the slide, the URL, sometimes we have to compare us with others, with third-party companies. So it's nice for us to see whenever we fail, okay, or whenever we are better than others, this to evaluate our tools to make them better. So we believe that it's also important in the case of security that if you have a firewall that is analyzing the traffic, that is very likely that to have some information that does not 100% matches what Suricata does, to see this information together, just like Alfredo was showing before, how to match them and correlate them, and how to make maybe Suricata better, okay, reading some information from others, or simply exploiting the investment, the economic investment you made to buy, let's say, a commercial firewall, and why not to use this information too, similar to what we are doing. And also another thing that we have done in ntopng is the automation, for instance, the downloading, periodic download of rules, let's say, coming from abuse CH, just to give you an idea, or to somehow to automate activities that are typically taking some time of Suricata users, because you have to do them offline. I mean, we have seen today nice extension to the version 5, but usually these are activities that are on the side. So the idea for us, in the future, we want to use ntopng as a collector of this information for double-checking if, for instance, the signatures you have in Suricata are enough for what you have to do, or if you have to enhance it, or in a way to merge everything in an open source tool. More or less, this is the idea. And so the work in progress box is something that we are doing. It is similar to what we have done for Suricata. So in essence, we read from Syslog, or we have to call some URLs. The URL will report us information in JSON format. We have to parse it and correlate it with flow information, or with let's say host, so in case there is a violation of host, and show everything in a user interface and to trigger alerts, like we are doing today. So just to wrap up, we want to say that today it's possible to have visibility and security with one tool, okay, respecting the feature of every individual tool, so to create something better. So we have done a nice work from a point of view of doing that, because we have opened our community to security that does not go and look just at the behavior of a host or for a network, but even go into a single flow and details of flow that only Suricata can offer us. So for instance, the flow, the file information is something that is relevant for some users. We believe that we have done a work that can be used by this community. At least this is the hope while we're here, because, for instance, we can bring new ideas or new possibilities to users of this tool. And I mean, talking about developers, we have heard before that they are searching for contributors. We believe that it's now time to put the packet inspection into Suricata, to move off this port-based detection to something, I would say, more modern. And also, we would like to, if you're interested, I don't know, it's not something we want to push, to talk about that, in particular for analyzing malware traffic in encrypted traffic, because this is, I think, it's an hot topic that, at least, our people feel, because most of the traffic that our people are analyzing is encrypted. So having something that goes beyond signature or certificate-based hashes, I think is very relevant. We also need some help on this, and I think will be a good way of exchanging our time, development time. Thank you very much. I don't know if you have some questions you wanted to ask. We'll be around next days if you want. Okay, thank you.
Thank you.